Hello. Hello.
Hello.
Yes.
Hello.
Yeah. Both are able to hear me, right?
Yeah, yeah.
Okay. Okay. So here in the web sphere MQ. Okay. So we have two components. Okay. One is MQ server. The second one is the MQ client. MQ server and the MQ client. So we have two components. Okay. So MQ server is the license. License, we have to pay, the organization has to pay the license fee. Okay, this is not a free version. So normally free version is available, but if organizations want to use, they have to pay the license fee. Okay, once we install the MQ server, so here there is a object called it as a queue manager. Okay, for example, if we install any database, we are creating a table initially for storing data. In the same way, once we install the MQ server on any machine, any physical machine or server, any Linux or Solaris or any AX servers, okay, first we have to create the queue manager object. Okay, so queue manager is the object, so which is responsible for providing messaging providing messaging and queuing functionality. Messaging and queuing functionality. Okay, so this queue manager also have objects. This queue manager also have objects. Okay, so what are these objects? Okay, for example, queues. For example, queue is a storage place. Okay, like channel. Channel is a communication link. Okay, so like topic, subscription. Okay, listener. Okay, so okay, listeners. Okay, so services. Okay, process definition. Process definition, name list. Okay, so etc. So all these are the queue manager objects. Okay, so if you want to use the messaging and queuing functionality, so what we have to do, first we have to install the MQ server. So what about MQ?
Again, sorry, this session you are recording, right?
Yes, yes. Okay, so this MQ client, this is the no need to pay the license fee. Okay, no need to pay the license fee. Okay, basically this is the free. Okay, when it is free, if we have organization is having the MQ server license, this MQ client is free. Okay, so okay, so we can install MQ client and the server, both are in same machine. Okay, so here there is no queue manager object, there is no queue manager. So basically client won't provide any messaging, client won't provide any messaging and queuing functionality. So it will be used to communicate. It will be used to communicate with the queue manager. So who will be used? Application will be used. Who will be used? Application. Application will be used to communicate to the queue manager. Okay. So one more advantage is using client. Application as a option. Application has a option to connect multiple queue managers. Application has an option to connect the multiple queue managers. So we have a specific one exercise for this MQ client. Okay. So now we come to know in WebSphere MQ there are two components. One is MQ server and one is MQ client. Okay. So the first step is the planning and installation. The first step is the planning and installation. Okay, planning and installation. So in a organization, according to the business scenario, means business functionality of the application. Okay, few applications are using MQ server to server communication. Few applications are using MQ client server architecture. Okay, so that is the reason we are involved on which missions we have to. Okay, so or which applications will go for the MQ server to server communication, or which applications will go for the MQ client server architecture. Okay, so based upon that we can install MQ server as well as the client. Okay, so that is involved in the planning. Okay, so when it comes into the planning, so the one is the we have MQ client server architecture. MQ client server architecture. Okay, so in this client server architecture, what will happen is, for example, I have okay, I have okay 1 to n applications in my organization. I have 1 to n application, maybe 10 applications or 10, 50, 100 applications, whatever it may be. 1 to n I have applications. Okay, all these applications, okay, to for business information, they get some information or they want to update some information. Okay, so all these applications are interacting with database, for example. Okay, so my database is db2. Basically it is into the COBOL. For example, it is into the AS400 operating system. Okay, so here in this is, for example, it is into the AS400 operating system. Okay, so this is AS400 on top of the AS400 operating system. So the db2 has been installed. So here I installed one MQ server here. On db2 operating system we installed MQ server. If we install the MQ server, okay, by default we don't have any queue manager object. Don't think if we install the MQ server, queue manager will be there. Nothing will be there. Okay. So once we install the MQ server, what we have to do? So we have to create the object called it as a queue manager. For example, my queue manager name is QMGRDB. queue manager shortcut, we are calling it as a QMGR. Okay, shortcut we are calling it as a QMGR. Okay, so on the database end, we install the MQ server, and we created the one queue manager, and we created the queues on queue manager. Okay, so here what is happening is here. Okay, so now all these source applications, now all these source applications, what it will do is, first it will establish communication to the queue manager. The queue manager is resided on AS400 platform. Here application and the queue manager, from this 1 to n applications under this queue manager are different missions. So it will use MQ client. So it will use MQ client to communicate with the queue manager. Then these applications are writing messages in this queue. These applications, okay, like 1 to n. Okay, so here, for example, queue name is, okay, request. Okay, queue name is request.queue. Okay, so like this, all see here, application under queue manager, both are in different missions. So application will use MQ client to communicate with the queue manager. Okay, so this is response.queue. Okay, so once this application is sending information, some business information to this established communication to this queue manager and writing message in this queue. Okay, in administrator point of view, okay, putting messages and getting messages. Okay, means putting means writing message in the queue. Okay, getting means reading message from the queue. Developer point of view, write message and read message. Write we are calling it as a putting messages, and read we are calling it as a getting messages. Okay, administrator point of view, putting and getting. Developer point of view, writing and reading. Okay, so this application is sending some information, just that the last demo we discussed, right? So in makemytrip.com, so this application we are searching flights from Mumbai to Hyderabad on 1st March. Okay, so this information means this information has been now here. Okay, so what this database application has to do? Okay, same way this application also establish a communication to this queue manager, right? And it has to read, and it has to read this information. Again it has to respond back to the queue. So here you may have doubt, for request and response I can use same queue or different queues. Okay, so for request and response, if we are using local queuing means source application, so under destination application, source application under destination application. Source is this one. Source is our source application is the this one. Okay, for example, web user interface. Target application is the our database. This is our target application. Source application and the destination application both are using only one queue manager. Okay, then we are calling it as a local queuing. So here for request message and response message we can use single queue, but in organization always segregation is required. Okay, so for example, if we have some airport or railway station, so it is a big airport or it's a big railway station. For incoming and outgoing, we have two different ways, right? Because so many people, okay, keep on going inside and few of them are coming outside, right? If you have a single, so it is very difficult to moving in and moving out, right? So that is the reason always segregation is required. So segregation is best thing. So for request message, all these applications will use one queue for writing message, and reading message it will use another message, another queue. Okay. So here the client applications are using MQ client, it is writing messages. Then target application will reading and again writing messages. So if application and queue manager are in different machines, so we have only one option, okay, client. But in other end, application and queue manager, application and queue manager, both are in same machine, right? Application and queue manager, both are in same machine. So how this application, how this DB2 application will communicate with the queue manager? Okay, so we come to know application and the queue manager both are in same different machines. We have option called it as a MQ client. If application and queue manager both are in same machine, so we have two options. We have two options. One is binding mode. One is binding mode. The second one is the client mode. The second one is the client mode. One is the binding mode. Another one is the binding mode, and another one is the client mode. Okay.
So I have questions here.
Yes.
So when you say when you use the binding board, it means, for example, I have got, let's say, 10 applications,
Hmm.
and if you want to use all the application on the server itself, which will mean that I would need 10 license.
Yeah.
But you think that's a that's a practical scenario in any organization? Do they use? Because I'm sure they might be using, let's say, hundreds of applications. So if we
No,
go
no,
in
they
for
have enterprise server license. Okay, you can install as many as. Okay, for each MQ server installation they won't charge. Okay, so every application, every business application won't use server to server. Okay. Okay.
and secondly, when you say AS400, is it equivalent to OZ? OZ
ZOS.
app?
Yes, yes,
Yeah,
ZOS.
ZOS. Okay,
Yes, yes.
okay, okay.
Okay. So binding mode. So binding mode advantage is, so here no network required. No network required. If you go for the binding mode, no network required. Okay. So compared to client, compared to client, so binding mode is very fast. Binding mode is very, compared to client, binding mode is very fast, but it can connect into the, so we discussed here, right? If we are using, if we are using MQ client, so we have a application, we means application has an option to connect the multiple queue managers. Okay, if we, if your application is using binding mode, it can connect it can connect one queue manager. Okay, one queue manager. Okay, so okay, it can connect the one queue manager. For example, here I have so many drives in my system. Okay, so if I want to copy some folder in from the C drive and I want to paste it into the D drive, do I require any network? No, right? If I want to send this document to you, any of you, I want required, right? I want a network required, right? So for example, I am sending this document into the D drive. At the same time, I am sending this document to all three of you. So which one is the fast? Sending it to the D drive is very fast, right? So, but in binding mode, we doesn't require any network. Compared to client, it is very fast, but it can connect into the only one queue manager. So it requires network. Okay, it requires network. Maybe some in three of you, both two of them, they were working, right? Maybe you are hearing about the channel. Okay, so here also we discuss channel means is a logical communication. It uses the network. Okay, So if we go for the client mode, we require the network. So if application and queue manager both are in same mission, it has a option either it can connect into the client mode as well as the binding mode. So in the client server architecture, only what is the disadvantage is always this queue manager should be available, or this for anything. For example, there is some ongoing maintenance, OS level maintenance in the AS400 system is happening. So this queue manager is not available. If the queue manager is not available, what will happen? All these client applications are not able to communicate with this queue manager. Okay, so so that is the only disadvantage. Okay, so here, so if we have a high volume transactions, then we will go for the MQ server to server communication, or mostly if we go for the asynchronous way of communication, then we will go for the so server to server communication. So in this client server architecture, in the source application, and we don't have any MQ server installation, simply we can use MQ client. So application will use MQ client, it will communicate with the queue manager resided in remotely, means destination application or whatever it may be. Okay, so this is the MQ client server architecture. Okay, so MQ client server architecture will client server architecture will be planned by like that. Then we have MQ server to server architecture. In server to server architecture, so what will happen? So in server to server architecture, what will happen? In source and destination, in both we have, means, so I have a queue manager here. I have a queue manager here. So I have a queue manager here. I have a queue manager here. I have a queue manager here. So I have my target application here. So I have my source application here. So here we have a queues. So this is the source application. This is the source application. So this is the target application. So what are the ways? So this is source QMGR. So this is the target QMGR. So if this application want to communicate with this queue manager, what are the options are there? If this application want to communicate with this queue manager, what are the options are there? What are the options are there? Just we discussed.
Binding mode.
Yeah, just we discussed it, right? Binding it is there, as well as client also it is there, because both are in same mission. So means, so it will use, so it will use either binding or client. If it is binding, so it will use channels. Type of channel is called it as a MQA channels. Basically channel, what is a channel? Channel is a logical communication link. If application want to communicate with the queue manager, it will use logical communication link channel. So type of channels we are calling it as a MQA channels. So it will write message in the queue. Then it will write message in the queue. So here, from here it has to be routed to the destination queue manager, right? So again it will use the communication link. communication link. So this is also channel. Okay, this is also between two queue managers. Okay, between two queue managers also the logical communication link also we are calling it as a channel. Okay, message channels, message channel. Okay, so application to the queue manager, so we are calling it as MQI channels. Between two queue managers we are calling it as a message channel. Okay, so through the message channel, so the message will be moved, so the message will be reached into the destination. Okay, so from
So Nagendra, yeah, so Nagendra, from in this binding mode, the channel, sorry, for one application to another, if you're using binding, how channel message or message channel is different from the networking?
no, if you
So
go
when
for this binding mode, you doesn't require this one MQA channel. When you are using MQA channel, if you go for the client, see here,
but here we
here
are using the binding. Yeah.
you have option, you can use binding, you can use, for example, here you created one more queue manager. If you go for the client, unfortunately this is not available. So if you are using client, automatically you can write message here. That kind of option is available if you go for the client. Okay, if you go for the binding, only you are able to communicate this one only. Okay, so this channel, I said, if you go for the client, okay, you are using MQA channel, application will use MQA channel, it will communicate with the queue manager. So here we have two options, either binding or client. If you go for the binding, it won't
So
come in the picture. Okay.
okay, so here right. So here on the source application, we are using the binding. That's fine. So from source to target, we will definitely be requiring the network. Can we say
Yeah,
that?
it between two queue managers we require the network, because this is one physical
Okay.
machine. For example, this is one. This is, for example, 10.1.2.2.2. Okay.
Mhm.
So every queue manager is listening one port number. Default is 1414. Okay. So this queue manager is another IP address 10.3.3.3. Okay. Okay. So okay, so definitely we require the network. Between
Okay.
two queue
So
managers we require the network. Application to the queue
okay.
manager only, we doesn't require any network if we are using binding mode.
All
Okay,
right. Okay, got it.
so
So
here,
right. So within the
yeah,
application,
so
if we are having the server, then we can use the binding manager or client, whatever we want. But
yeah,
would definitely be requiring, but would definitely be wanting to use the binding if we are using this mode, right?
yeah.
Yeah. Okay.
So here, okay, so here you have to understand MQ will provide the routing functionality, means transportation facility. It will provide the routing mechanism, means transportation facility, means, so here MQ won't insert any data into the destination application, or it won't retrieve any data. Okay, simply application is writing messages and application is reading messages. It means application responsibility, application responsibility to write, and to read the messages. Okay, application responsibility to write the messages as well as read messages from the queues. Okay, so MQ just it will provide the communication. Okay, so in the, if you go for the MQ client server, what will happen? So we can use at the source application and we can use one, and at the target application and we can use another one. Okay, so this way, so here, so here the communication, for example, this target queue manager is not available. Okay, maybe this queue manager is available. Okay, but between these two, okay, communication link has been failed, network has been failed. This source application is communicating asynchronous way. Okay, it can keep on writing messages. if the target is, if the communication failed or target queue manager not available, not an issue. This source application keep on writing messages. The messages are lying in the queue because queue is the storage place, right? So whenever this communication is available or this queue manager is available, then the message will be delivered to the destination. Okay. In client server architecture, if the destination is not available, application is unable to write message. But when we go for the server to server, if the destination is not available also, source application keep on writing messages. Whenever it is available, then it will be delivered to the destination. Okay.
So,
So
so when you use, suppose we are using asynchronous, which means we are expecting the response back, yeah?
no, asynchronous means you are not
Okay.
expecting the response.
Oh,
Okay.
okay.
But if you are expecting response, here it is application is waiting, right? But your messages are not delivered. Okay,
Yeah.
or asynchronous. Okay. So that is the MQ server to server architecture. So if you, then you can go for the one more scenario, hub and spoke. Okay. So if you have so many installations you doesn't require, okay, then you can install the MQ server in centralized. Okay, you can install the MQ server here. Okay, so your source application and the target applications are communicating with this queue manager like client server architecture. Okay, so your all source application and target applications will communicate using MQ client. Okay, we'll communicate with the MQ client. Okay, MQ client. Okay, so just it is writing messages in the queue. Okay, and reading message from the queue. So like local queuing. So here, so all source and target applications will communicate with the queue manager, and it is writing messages and reading messages. Or if you want different queue managers also, here you can create. So source application will communicate with this one. Target application using client, it will communicate. Again here also you can establish. But these two queue managers on same machine. Okay. Okay. So if you want to reduce the number of MQ server installation, again you can install. Just you can logically interconnect these two for high availability, workload distribution and high availability clustering mechanism. Okay. So if you want to reduce the number of installations, okay, so you can install the MP server in the, okay, one centralized system. So all your applications will communicate with the that are MP server installed on the centralized system. Okay, so in this way we can plan it. Okay, so after planning, so what is the next step? Installation. Okay, so whenever we will go for the installation, whenever we will go for the installation, okay, so IBM is providing the few prerequisites. Okay, so installation is very easy. Okay, whether it may be Windows or Linux or AX or any operating system, mostly it will completed in the 10 to 15 minutes. Okay, so installation is very easy. So while installing, what IBM is suggesting, follow the few prerequisites. Okay. For example, anyone ask you, have you ever been installed MQ? Yes. So tell me what are the steps you are following. Okay. Steps means first we have to say the prerequisites. Okay. Prerequisites, not a direct installation. Don't say directly installation steps. So in order to install the MQ, so first of all, we are following the, these are the, we are following, okay, these are the prerequisites. Okay, don't say, okay, so direct installation steps. Okay, so what are these prerequisites? The first one is the mqm on point creation. Okay, so for MQ installation around 600 MB is enough. Okay, but we are assigning, for example, 10 GB space for this mount point. Okay, so why mount point is required? Okay, why IBM is suggesting why IBM is suggesting mount point is create a MQ mount point. Okay, so in my system, so I have three drives. Okay, C drive, D drive, and E drive, right? So these three are the mount pointers, right? So here I have only 33 GB space. For example, I try to put 40 GB, 35 GB file into the C drive. So will it take? It won't take, right? Means it won't copy it, right? But the machine is same, but I have here 245 GB. I have 42 3 GB, 42 GB free here. But it C drive won't take the space from D as well as E, right? Okay. So why mount point? It is recommending mount point is, if we install the in a organization on a particular server, there are so many applications are installed and running, right? There are so many applications are installed and running. If we install the MQ, okay, if we install the MQ on common mount point, if at any point of time, if there is no space is available for this MQ, so MQ server is unable to provide messaging and queuing functionality. Okay, if we have a specific mount point and a specific space, always MQ doesn't have any space issues. So you may have faced so many times space, regarding space also application will not functioning, frequently taking the archives, backlogs, archives, and purging, right? So if we have a sufficient space, for example, my MQ, I am assigning 10 GB for this mount point. Always it is using 1 GB. 90% of the space is ideal for this. Okay, I don't want to bother about that. Okay, regarding the space issues. Okay, so that is the reason. Okay, always mount point is the required. Okay, so the second one is the MQM group creation. MQM group creation. So why MQM group creation is mandatory? Why MQM group creation is mandatory? Only MQM group users. Only MQM group users can create or alter WebSphere MQ objects. Can create or alter the WebSphere MQ. Okay, can create or alter the WebSphere MQ objects. So the users which added in the MQM group, those are able to create or alter the, create means creating the queue manager and its objects. Okay, and alter can do. Even root user also can't do. Root user means nothing but the administrator. Okay. So the third one is the create MQM user. So then the fourth one is the add MQM user to the group. Why we are adding MQM user to the group? Because only the MQM group users can create or alter the WebSphere MQ objects. That is the reason. Okay. So then fifth one is the installation. Installation should be the root user. Installation should be the root user. Nothing but in Windows it is the administrator. In Linux we are calling it as a root user. Right? After installation, only installation should be the root user. After installation, what we are doing? After installation, what we are doing? Configuration. When it comes into the configuration, using configuration for using MQM user. Okay, configuration of WebSphere MQ objects. Okay, using MQM user. Okay, using MQM user. So we are configuring the, okay, we are configuring the WebSphere MQ object. So who will do all these things? So these two will be done by the MQ admin or middleware admin. Okay, so all of you know, maybe you are aware of this also in an organization. Okay, mostly the system will be controlled by the sysadmins, right? System administrators. Maybe you are familiar, you are into the system administrator, you are looking into the system operations as well as middleware operations. So then you are involved in this. Okay, so but most of the organization, 90%, these will be different teams, and these will be the different teams. Okay, so in order to install the MQ server on this physical machine, these are the prerequisites has to make. So then we raise the request, they will done it for us, then we are performing the installation activity. Okay, if your system admin and middleware admin both are same, then you are involved in this. Okay, hello.
Yeah, Nagendra,
Yeah,
yeah.
yeah. Okay.
So when you say mount point creation, Nagendra, is it on the server or the client side? For example, I want to use this, MQ. So this mount point creation will be on
For
my
server,
desk or at the server level? On the server,
for
no? So okay.
yeah.
So what is by the way the mount creation is mount point creation? Mount point, what is where the queue resides? Is the
No,
storage
no,
space where
no.
the queue is?
Storage
Yeah,
server. See, you are like C drive and D drive, right? For
yeah.
MQM, you are creating one drive, okay, one mount point. From there, you perform the installation activity. So it will use that space, this 10 GB space. Okay.
Okay, so that will be used to store my messages and all, yeah?
Yes, yes, yes. See, whenever
Which
you
I can
create a,
archive periodically.
whenever you create the queue manager, one file system will be created. Means by default queues, channels, all these 77 objects will be created. So it will occupy some space, right? So all these will be using this space.
Is it archivable in the sense, do we have a practice of archiving this space sometimes? Maybe 3 months, once or 3 months or 6 months time.
No, no, not required this archiving. Okay.
So it's an ongoing process. So I think all we do, we just keep adding the extra space to this group.
No, no, doesn't require. We have a logging mechanism. Okay, different types of logging mechanism. So one is it keep on rotating logs. Okay, it will
Okay.
overwrite the all log files. Okay,
Okay.
no need for the archives. Just we are taking this object definitions backup. Okay, okay.